Okay, boys and girls, we're going to graph the function f of x is equal to x squared. We're going to use our TI-84 in order to do this. Press your Y editor, which I'm in right now. Type in x. You can use the square button, which is right here, or if you just want to raise it to a power, you can do that also. Once I graph it, press graph, and here's my parabola. Right? It's concave up. Looks like a smiley face. In order to find the different parts of the graph, what I'm going to do is I'm going to go to the table, and if I look, I can see that I'm starting at a high point, decreasing, going lower. I get to 0, which is the lowest point of these outputs, and then it starts to increase. So this is where my turning point is going to be, right? Or somewhere in that location, because sometimes it's not a whole number and it's not located. But for this graph, it is. So we're going to start by first taking our numbers and entering it in the table. I have -3, 9, -2, 4, -1, 1, 0, 0, and then 1, 1. I'm going to go to my graph, and I'm going to start to plot these points. So -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And if you look at the points here, you can actually see these points are equidistant from this axis, which means this axis is the line of symmetry or the axis of symmetry. Okay. Once I have my points plotted, I'm then going to connect them. Now this isn't a straight line, so you don't need a straight edge. What it forms is a curve, right? And that curve is called a parabola. Okay, so you're sketching the graph, right? This is a little more difficult than doing it on paper, so it's okay if it's a little messy. You want to graph your function. You want to label the function. Okay, try to make your points visible so you can see them later. Okay, and that's a graph of y equals x squared. Now we're going to move over and identify our different pieces. This is a concave up function, right? It looks like a smiley face, right? With a concave up function, it has arrows on both ends, which means that these arrows are extending forever. So this will go in this direction, this will go in this direction, and there is no limit or there's no maximum height to this function. This function actually has, if you trace it all the way down, it does have a lowest point. This lowest point is the vertex, right? So we'll label that as 0, 0. Right? And that's where the function turns. It's also referred to as a minimum point because here it's the lowest height. Okay, so we're going to cross out max and just write it down as a minimum. The x-intercept I can find by looking at the x-axis and seeing where the function crosses. It crosses right there at the origin. So it's going to cross where the x-coordinate is 0 and the y-intercept too is 0 because it's at 0, 0. If I was then to take a dotted line, take a different color, right, a dotted line, and draw that dotted line through the vertex, this would divide my parabola into two congruent pieces. This is referred to the axis of symmetry. Its vertical line starts with an x, and it actually has the same number as the x value of the vertex. Okay. We said before that this graph is concave up, so we'll keep it that way. The domain, because there's nothing restricting it going along the x-axis, I can look at any point on the x-axis and there will be some kind of output, even though it's very high up. But there is no restriction, so the domain will go from -infinity to +infinity with parentheses, right? Or calling it all real numbers. Okay, the range is a little bit different. The range does not have a maximum height because of the arrows, so it's continuous. but it does have a minimum. The minimum here is 0. That's the minimum y value of the function. So it's a bracket, comma, parentheses. Okay, and that is the graph of y equals x squared.